Hello and welcome to Tribetopper. I'm Sonal Gupta, and this channel is about increasing your understanding of physics. To clear your concepts, subscribe to our channel and click the bell icon for latest updated videos. In this video, you are going to learn about the electric field strength and surface charge density, a relation between the two. So let's consider a parallel plate capacitor, right? Or we can say two parallel plates with an opposite charge. One has a positive charge, the other has a negative charge. Now, what is the capacitance of a parallel plate capacitor? We have learnt that in topic 5. So, capacitance is given as the charge that is attained by a capacitor over the potential difference applied. So C is equal to Q by V, which implies Q is equal to C times V. We also learned in that unit that the capacitance of a parallel plate capacitor is given as C is equal to epsilon naught A over D. So we'll equate the two expressions and I'll substitute the value of C to be epsilon naught A by D here. So that gives me that Q is equal to epsilon naught A upon D times V. We bring this A here down, which gives me Q over A, that is equal to epsilon naught times V upon D. Now, what is the purpose of bringing A here? Q upon A represents what? Q upon A means the charge acting over a unit area, which is known as sigma, the surface charge density. So the surface charge density sigma is equal to, I'll say therefore sigma is equal to epsilon naught times V upon D. And in a previous video we learned that V upon D, the potential difference variation with distance, that ratio is also known as electric field strength. So that gives me sigma is equal to epsilon naught E. So if I want to find out the electric field strength in terms of surface charge density, I will say therefore E is equal to sigma over epsilon naught. This is the electric field between two parallel plates, where each plate contributes half of the electric field. So if I want to say what is the electric field contributed by each plate closer to each straight conductor, that would be equal to sigma upon 2 epsilon naught. So each one would contribute sigma over 2 epsilon naught and they would add to give you a total electric field of sigma over epsilon naught. So this gives us the electric field strength in terms of the surface charge density of a plane conductor. So that's all for this video session. In our next video session, you're going to learn about the electric potential and potential energy. Thank you.